It's got stilts and stuff as well. Plastering.
Oh, is it?
Yeah. You can see the arches on the ones on the left, they're sort of higher up. Is that a barrier?
Consultation. You work, so you have both working together. Wow. And then you okay, we're to go in and park in the visitor parking area. That's what I was told.
What's the purpose of the tour?
Education. Witness each other. Those are not the boom that's put off for. There is a plan here in the next few years to build this dam up. So we can have more of the lake.
The next day, you had about 2 meters shooting over top of the compressor ring. And they basically cut right through this whole parkway here. It's meant to go that way. It would take a long
So now the water is going to leave that raw station. Yeah. Basically, it's going right where the gentlemen with the blue coatings are, straight up the
And a mega is a million or
million liters.
Oh, look, what is that?
Yeah. Yeah, they're all over the place here. Again, is it running full tilt all the time? Thank you very much.
Thank you.
Appreciate it.
Thank you.
Yeah. Thanks very much for looking after us. Yeah, appreciate it.
Thank you. Thanks for coming.
So, the next place we're going is Bonnybrooke, which is the wastewater treatment plant, one of 2 or 3, Charles? 3. And they should explain that process, and hopefully we'll get a similar kind of tour. And I realise it's a lot to absorb. Whenever I spoke to them and said we're doing both things in one day, they're like, what? How? But it was our chance to get in and to see that too.
So it's a real pleasure to have you here at Bonnybrooke. And what we've got planned for you today, we wanted to give you a bit of an overview about where you are and what happens at this site. We know you've seen lots of plants and pumping water, so we thought, let's get them into the lab and you can see why we're doing what we're doing. And really here at a wastewater treatment plant, it's about treating the water before it goes back to the river. This is where all of our big capital dollars, you may have heard in the paper today, the council approved that all of the new developments are going to pay for themselves and our new plant upgrades. We're putting in the next 8 to 10 years, $600 million of upgrades in this site alone. We have 3 wastewater treatment plants. Our newest one, Pine Creek, in the far, far south, we would not have been able to build east and south in the city had we not put that in. It's really essential, and we're really kind of pushing the limits at this plant. So those upgrades are really needed. Ultimately, it's about a river that you've seen where it comes from, where it goes. It's about what's going on in that river, and the fish in particular are one of those species that tell us first what's going wrong, if it is. Calgarians ultimately use that river, and of course people downstream. We're a large city. When the water leaves our city, it's in a different state than where you saw it on Monday, definitely. So those are really important things. What's interesting here at the plant is the limits. Every 10 years we have to renew what it is that we put back in the river, the rules, our approval. That's up for renewal in 2 years, and every time they open that up, it gets more stringent. The feds didn't used to be involved, it was just the province. For the first time in our approval, the feds are in there. We're doing fish studies right now to try and figure out all the city growth, what's going on. We used to have 2 parameters that we really had to monitor for, TSS and phosphorus. Nitrogen is on the table. What are we doing about that? Things are getting tighter, and so the science improving in what we do every day and what our impacts are and what we forecast those impacts is incredibly important. So that's where our science geekiness and getting in there and working with a variety of folks to figure out what's going on is really important.
We have you flush your toilet in the morning. Who did that this morning? I'm sure everyone. So it gets collected through the pipes under the ground all over the city, and it comes to one of our 3 wastewater plants. So at the beginning of our plant, we have a building we know as Headworks. At Headworks, it's a big series of screens, and all it does is simply screen out the things that people shouldn't flush down the toilet. Dead snakes, diapers, false teeth, whatever. So there's a series of screens. These things all screen the material. It gets put on conveyor belts and it goes to landfill. But it's really important in the process that we screen out that big clunky stuff that probably shouldn't have ended up in the wastewater plant to start with. Also, there's some settling chambers that remove some grit and dirt and gravel and various other things that end up. Next step, between these 2 steps, the primary clarifier and Headworks, we call that primary treatment. Basically what happens in the primary clarifiers, the sewage comes in, has big stuff removed, and it has spends a few hours here, and the big stuff is just allowed to settle out. So there's constant inflow, constant outflow, but it's basically the water comes in at the bottom, rises to the top, spills over and carries on, and the mud and the dirt and a lot of sludge and whatever is just allowed to settle out. Then it goes to our bioreactors, and these are my favorite part of the process because it's biological. So what happens in the bioreactors is it's living organisms, bacteria and whatever, that are allowed to spend a certain amount of time with the primary treated sewage, and those bugs, they take up phosphorus, they take up nitrogen, they break down organic carbons, they break down pharmaceuticals, they break down all these sorts of things. And these are really the workhorses of our wastewater treatment plant. And it's about removing phosphorus, removing nitrogen, removing the harmful chemicals, removing the nutrient loads, those things that can be harmful to the river or to the human beings. After that, because the biological treatment process in the bioreactors, we add biomass. So when you go to the lab, you'll see what some of this activated sludge looks like. It has to be removed as well. So then it goes into a secondary clarification step. And we can spend about 16 to 18 hours in this, and the bugs grow, and we just keep producing more biomass. Then we need to settle it out before it can go on to be disinfected and then go to the river. So we do some additional filtration after that. Our disinfection is by UV disinfection for the pathogens. We don't add any chlorine at these plants in any way. So we use UV disinfection before it goes back to the river. So that's what happens to the liquid stream. As I said, we also have all this there's biomass that we add to these reactors which produce biosolids. So when they settle out in here, we're building literally truckloads of goo that also needs to be treated, and we have processes for that. So those are all collected. Some of this is returned back to the front end of these bioreactors as the new seed stock to keep those bioreactors constantly going. But the excess has to be further treated. So it goes to an anaerobic digestion process where it is digested. And then it goes out to the shepherd lagoons where it's further concentrated. And we have a program known as CalGrow in Calgary. And CalGrow produces fertilizer. So these digested biosolids are then put on trucks and injected into the ground. Some of it, we have more biosolids than we can apply in agriculture. So some of it has to be treated other ways. And some of it will be going to our new composting facility that the city is building in 2017, I hope, as well.
And we are going to divide into 3 groups. And what we're going to see in the lab, we're going to go down the hall and we're going to put on safety glasses. Nobody's wearing high heels today, so that's great. We're going to divide you into 3 groups, and one will have a look at our advanced instrumentations where we're looking for the really, really tiny chemicals, and then we're going to look at some water samples at different stages through the process, and then we'll also have a look at some of the bugs under the microscope, which is really, in many ways, wastewater treatment is like a big zoo. And that's,
Nancy calls it the zoo in the poo.
Zoo in the poo is really what a wastewater plant, so we're going to have a look at that as well.
We disinfect everything before it goes back to the river. Right. So the good stuff is part of our activated sludge process. That was that process that I was talking about where we recycle it. So a couple of times a week, the girls here in the lab actually look at that physically under the microscope. And we are able to help wastewater treatment with, is their sludge healthy looking? Is it balanced right? Is it where can we get the best performance? There's also some bad things in there that we don't want them. So that was actually the subject of the Bee Kingdom work, is they created some very lovely pieces of glass on some of our beneficial microorganisms. So I think the girls want to show you some stuff. Do you have a slide under the microscope? So this is part of the secondary treatment process, and this is where we take the good bugs and we mix it with the sewage, and we let them incubate in the bioreactors for a period of hours. The length of time is dependent on what the flow of the sewage coming into the plant. Like, we don't have controlled flow. It's as things come in, the flow rate is naturally set. We see that as a really healthy looking sludge. So, is that an air bubble or an amoeba knife?
I'm gonna guess an air bubble. Let's see if I can find.
We take tons of pictures.
Oh.
If you ever want pictures of any of these,
Oh, look at you. There's a paramecium.
Paramecium.
And this little guy is a tardigrade, otherwise
water bear!
affectionately known as water bear. This dude, right here.
Yay.
Yes.
Oh, it's very rare that you don't get to see water bears every day.
No.
Wow.
And now they look like they're having a dance party.
So
That's not
the
something.
paramecium, that was another subject of Bee Kingdom,
Yeah.
and the water bear was too.
Yeah.
These particular organisms don't do much of the good work, but they're an indication to us that the environment in the sludge is suitable for the ones that do good work. And the bacteria that are really doing all the work are really, really, really tiny.
Yes.
You actually can't see them.
Right.
But so that's why we use these bigger microorganisms as the indicator of, do things look healthy?
Oh.
The first bottle in here is the influent. So in Calgary, the domestic waste and the industry waste are discharged to the sewer system, and then eventually all reach the headwork at the Bonnybrooke. We have 3 facilities: Bonnybrooke, Fish Creek, and Pine Creek. Right?
Explain that
Already, yeah. So the Bonnybrooke one influent look like this, and you see some
So I told you,
particle.
raw sewage doesn't look like you expect raw sewage to look.
Yeah, and this is after the grit, which is the big particles already removed. Yeah, so this is what look like.
Going into the settling tank.
Yep, primary clarifier.
Yeah. And after this one, and it goes to the secondary clarifier, and the secondary clarifier will have some gravity settling, and this is where it's separated the solid and liquid. The liquid part will go through all the biological process, and eventually will look like that. And someone was asking about the color, but the color was a bottle, so this is actually what's being discharged to the Glenmore Reservoir, right? And
That's after the UV.
after the UV, yeah, after the UV. And this is the liquid portion, the solid portion, which is from a primary clarifier, and it was by gravity settled at the bottom and then discharged to a different process channel, and it gets called a sludge process. And you see this is what come out from the bottom of the clarifier and goes through the fermenter system, and the process eventually goes to a digester being digested. And after the digester, the sludge will pump to the Shepherd Lagoon, and it will be used for our cowgirl project, cowgirl for the farmland.
So when you take it away, from here,
it's pumped. Yeah.
Still liquid enough we can pump it.
wow,
Yeah.
I didn't know that. All the way to Shepherd.
Yeah. So sorry, depending on the stage, some of the raw sludge is very strong. This is
So,
Tasty.
Susan, do you have an example of RAS?
RAS. I do.
Okay.
Put in a blank tank, and it's not still not fermented. After the fermenter, the odor it's become a less. Yeah, and by the time it reaches the digester, it's really just nice.
Wow. So when they inject it in the fields, when they've gone through that process, is it dry or wet when they do it?
Wet.
Still wet.
wet.
It's slurry. We are considered to have a very almost state-of-the-art wastewater treatment for North America, and whoever, Marco, do you know who gives this the A+ rating? Where does that come from? Do you know?
Ooh, I knew.
Sierra Club.
Sierra Club out of BC.
Yeah.
Is it Sierra Club?
I think
Or
so.
something along
Is it?
those
I don't
lines?
know.
It was the last
Okay.
one.
Yeah, so they do some sort of ranking system for wastewater plants, and we do receive an A+.
Last year
So-
was number one.
Were we? I didn't know that. How did I miss that information, Susie?
Pictures of the email.
Apparently, I was busy that day. Sludge, so this is what we use to feed the bioreactors. So the stuff, the sewage that comes from the primary clarifiers is mixed with this, and that's the good bugs. We have to keep feeding it back to the front of the system. A new piece of equipment that cost us how many dollars?
About 140,000.
So $140,000. It's called an iron-coupled plasma.
Inductively coupled plasma mass spectrometer.
Yes.
Long name, yeah.
ICP-MS.
ICP-MS for sure.
And this particular instrument is what we use to analyze metals at parts per trillion concentrations. So part per trillion, drop of water in the saddle dome. I don't know if that is helpful, but yes, we can detect things at those levels. This particular instrument does metals. I will let Matt give his spiel.
All right, sounds good. So as we had mentioned earlier, Norma mentioned earlier, analyze instruments is for analysis of metals. So maybe I'll just go through a brief summary of how it works. So what happens is over here we mainly analyze matrices, water, wastewater. So water being drinking water, could be river water, surface water, storm drainage waters, and of course wastewater is from the plants. So what happens is when we get the samples, it gets preserved in nitric acid, and after that it gets processed. So depending on what type of method we're looking at, some samples need a more rigorous sort of digestion, so we use a stronger concentration of acid to digest and really break down the sample. So besides water, this can be used to analyze soils, sludges as well, but we mainly analyze water matrices here. So what happens is we have the samples, we bring them here after it's been preserved. We put them in the little tubes and in a rack. So that's the Autosampler. It basically is automated, takes up the sample, brings it through the tubes and into the instrument. So if you could see here, how it works is that it runs using a carrier gas called argon, which basically carries the liquid through, and it gets aspirated or nebulized into really fine droplets, which then it gets carried into the torch. And in the torch there, you see some coils, and that's where magnetic field generates the plasma, and that plasma is really, really hot plasma. Working temperatures around 7,000 to 9,000 degrees Celsius. So that's like the temperature of the surface of the sun or hotter. But anyways, really need that hot temperature to ionize the sample, and the metals get ionized, they become ions, and they get carried into the instrument. So in the instrument, there is a section called a quadrupole, where there are basically rods that have some magnetic field in it to separate or filter out the charges, the ions that go in by mass to charge ratio. So each metal has a different mass.
It's also chemistry, right?
Yeah. To charge ratio, it gets brought in, and basically after it gets differentiated, it hits the detector, and the detector amplifies the signal, and you'll see it on the instrument. So as Norma had mentioned, with these new technology, you could see really, really low concentration of metals.
What you just learned that our entire process is biological, and then we're dumping extremely high levels of zinc into our wastewater plant, and that can cause upsets. So again, part of the work that Mantat does is being able to, it's less about what we see than the changes in what we see are a lot more important in helping us identify. Then we can go back to an industrial customer and say, we need to work a little bit on your process because you're not being too helpful to our wastewater process. People sitting around wondering what to do with their time. There are times in the summer with our stormwater and drainage programs.
Someone might, I have a concern about something leaching into water.
Or it could be to basically remedy the situation that we've found on site. Sinks with pipes on top of them, so you're trying to undo 4 bolts under a sink, and it's not very pleasant.
But basically, they should monitor it, and then they'll have like a hazardous company or hazardous waste disposal company. They'll pump out the oil off the top, and then they'll back out the sediments to the bottom, and then clean it up that way. It's a fairly simple design. They vary a little bit, but they're often a 2-cell system. Paperwork yet? And I got back to the office, and you already sent me an email that he had a trucking company in, pumped it out, and that was within a couple hours. They got it done right away. So
we're unique in our buried infrastructure is a mystery to everyone. People in the city you don't really think about it. When you're driving down the road, you don't realize that there's 3 sets of pipes underneath you. So we even have things, our storm system and our sewer system are completely separate entities. So anything that enters our storm system actually ends up in our rivers. So you'll hear stories about people with their RVs parked over manholes releasing their black water, right? They think they're doing a good thing, that they're putting it in the sewage, but they don't know that it's actually in the storm system. So, there's something. People in general want to do a good thing by their environment. We just have to help them do it. We just have to help them a little.
So none of the stormwater is processed, is it?
It can be processed on site. We do have stormwater facilities like ponds and.
Right, but I'm saying
none of it comes here to this facility. So it will either go directly into the river, or we'll have some form of preliminary treatment, whether it's a retention system or a rain garden or
all of which separates them. So thank you all very much.
Yeah, we love that.
Super cool. Yeah.
Well, the girls will be happy to send you as many pictures of water bears as you can stomach. And you can see, pay attention, there's a beautiful one in glass at the water center.
Yeah. And thank you, but I had no idea. I've seen you in the water center. I know, but I had no idea what you did. So I really appreciate you talking about that side of the business too. So it's super.